let's take a look into the space-based architecture style. Before we'll go to the topology, let's say a few words what it is about, what this style is about. In case, if we'll take a look for the most of the web application, the general flow of the request is the next, that the request receives from the user into the browser send the request to the web server. From the web server, it goes to the application server and to the database. It can work quite well, but since the moment when there will be a huge amount of users, or it will be quite big load, then it can bring additional challenges and issues. What it means, how you will resolve the issue when then in one particular moment there will be high user load, so the user load will increase. Then for maybe it can be resolved in a case like, okay, we'll increase the number of web servers, so we will scale the web servers. Good. So what it means that you will resolve this particular issue, but the next bottleneck on this workflow, on this pipeline, it will be web servers, application servers. So in this moment, it means that, okay, we'll try to scale the application servers, and it will be also not always easy to do. It will require additional efforts from the development team, and they should have to guarantee and provide the thing that the behavior will be still predictable in case if the number of application servers will be increased. But what will be the next situation? Okay, you will scale the web servers, you will scale the application servers, but next problem will be with the database. So it means you will need to scale the databases, you will need to have replicas of this information for the databases, and it will be much more complex, and this is one of the most expensive things to scale. So yes, of course, it can be one of the way to how to resolve with such situation when you will have quite big lot of users, but it is proposed to, instead of this one approach, it is proposed to use space-based architecture styles since the beginning. So if you know that the system that you are designing, you can face with situation with high load of users in particular moment, then maybe space-based will be the better choice. So in any high volume application with large concurrent user load, the database actually will usually be the final limiting factor in how many transactions you can proceed concurrently. Of course, you can use some caching technologies, database scaling that can help you to resolve all of them. But the space-based architecture style is specifically designed to address problems involving high scalability, elasticity, and high concurrency issues. It is also a useful architecture style for applications that have variable and unpredictable concurrent user volumes. Some extreme situation. Now let's take a look for the topology. So high scalability and high elasticity, yes, and high performance are achieved by removing the central database as a synchronous constraint in a system, and instead leveraging replicated in-memory data grids. So application data is kept in memory and replicated among all the active processing units. So this is basically the idea of this approach, of this architecture style. So instead of, if we know that we can scale web application, we can scale application servers, but the most complex will be scaling of database and replicating the data. That will be the bottleneck of all of the things. Then let's try to remove this bottleneck, this issue, by what? By keeping this information in memory in each processing unit, and each processing unit will synchronize this in memory data between each other asynchronously. When one of the processing unit will update the information in one of the cache or memory grid. So using it will replicate this cache through all processing units. And in case if you will have high volume of user in particular moment, it will be much more easily to start one more processing unit to scale your application as much as you need. So this is the basic idea of this architecture style. But perhaps there are a lot of components that is not clear right now what it is, what is processing unit, what is the messaging grid, what is the data grid, what is a deployment manager, what is data reader, data writer, how they can be implemented, and so forth. So let's go deeply and try to figure out each of these, each of the points. First will be the processing unit. So the processing unit contains the application logic. So application logic should be inside of this processing unit. You can think about it as a service. This usually includes web-based component as well as backend business logic. So it should include some web-based and backend also business logic. Smaller web-based application would likely be deployed into a single processing unit. So if it can be one deployment unit, whereas the larger application may split the application functionality into multiple processing units based on the functional areas of the application. So both of them is valid. It depends from how big the application it is. So we can see here we have component in processing unit. They work within memory data grid cache and data replication engine that will replicate data through different processing units. Another one part is virtualizing middleware. So what it is, virtualized middleware. The virtualized middleware handles the infrastructure concerns within architecture that control various aspects of data synchronization and request handling. The components that make up the virtualized middleware, it includes messaging grid, data grid, processing grid, and deployment management. Let's take a look for example, messaging grid first. So what it is, messaging grid. The messaging grid manages input request and session state. When the request comes into the virtualized middleware, the messaging grid component determines which active processing components are available to receive the request and forward the request to one of those processing units. So we have the number of processing units, and depends on the load, from which of them is not so much loaded, which of them is on the rest, and he's just waiting for a request. Then messaging grid take a look for which processing unit we should forward this request to balance all the requests and make the system available. I will tell you right now immediately some of the examples. Maybe it will be much more easily to understand where these architecture styles or pattern can be applied. Let's say we need to design the system that need to sell the tickets for some rock star concert, for example. And we know that selling of the tickets for this concert for this rock star will start in particular date. So and we expect that a lot of users will try to buy the tickets at the beginning to select the seat or the best place. So we know that, for example, for 1 week the selling will be closed, and we don't expect high lot of users. But when the selling of these tickets will be open, then we expect that there will be high volume of users that will wish to buy the tickets specifically in this moment. If we will design the system in a regular way, so we will face with bottlenecks with transactions in the database level in this case. It's at this particular moment, so the system will just failed. There are 100 of examples. For example, you want to book something on some time, on particular time, and you know that the opening time to book will be some specific, or you want to buy ticket for the train since one like day before, and such cases. So in most of the cases, if you see that system is not available due to the reasons that like a lot of request is coming in particular moment, since this system was designed in a wrong architectural style. In this particular case, when we will save all information in memory grids, so we will not face with issues with transaction on a database level. And we can replicate and scale this processing unit as much as we need at such moment. So in this moment, when we will start selling the tickets for the Rockstar concert, we'll increase the processing unit as much as we can, and the messaging grid will just load balance this through the all available processing units. So we will not have like a peak time when there will be some requests that we will not be able to handle. Next is a data grid. So the data grid is implemented solely within the processing units. You can see inside as a replicated cache. So this is kind of cache that is replicated. However, for those replicated caching implementations that require an external controller, or when using a distributed cache, this functionality would reside in both the processing unit as well as the data grid components within the virtualized middleware. So since the messaging grid can forward a request to any of the processing unit available, it is essential that each processing unit contains exactly the same data in its in-memory data grid. So the responsibility of data grid is to synchronize this data between all processing units. That all processing unit will work with identically the same data. The processing grid is an optional component within the virtualized middleware that manage orchestrated request processing when there are multiple processing units involved in a single business request. So in case, this is quite optional, but in case if multiple processing unit is required to handle one of the case, one of the business logic case, then in this case, this processing grid will be in the role of as an orchestrator. It will orchestrate requests between this processing unit to handle this functionality. Deployment manager component manage the dynamic startup and shutdown of processing unit instances based on load conditions. So based on load conditions, the deployment manager will decide, okay, in this moment, I will need to start up more instances to handle the load, or okay, we don't have too much request coming, no need to spend resources of processing unit, we can shut down them in this, for example, this is a night time. Yeah, the user are sleeping. Nobody uses the system at night, for example, or just one instance will be enough for this moment. Why do we need to run all of this instance at this moment? So this is a flexibility. So this component continually monitors the response time and user loads, start up new processing unit when the load increases, and shut down processing unit when the load decreases. Another component that you already see on the topology is data pumps. What it is, data pump? Data pump is a way of sending data to another processors, which then updates data in a database. So processing unit do not directly read from and write to a database. There is intermediate level. There is something as a proxy between the processing unit and the database. And this is the data pumps. So data pumps within a space-based architecture are always asynchronously. So we send and forget, and sometimes later it should be processed and put it into the database, providing eventual consistency within in-memory cache and the database. When a processing unit instance receives the request and updates cache, that processing unit becomes the owner of the update, and is therefore responsible for sending that updates through the data pump so that the database can be updated eventually. So one more time, the request comes to one of the processing units. One of the processing unit update the information in the memory grid. Yes, we have data grid that should synchronize all of the memory grids inside of the processing units between them. But still, each of the processing units is responsible to update information in the central database. And this update should be done not in a synchronous way, but instead of by asynchronous communication. And to achieve this, we will use the messaging. So messaging is a good choice for data pumps when using the space-based architecture style. Next, it will be data writer. So data writer components accept message from the data pumps. Data pumps is like a queue implementation, and update the database with the information contained in the message of the data pump. So we have here as an example customer data writer. It will read information from data pumps, and the responsibilities is that to write this information to the database. Data writers can be implemented as a service, application, or data hubs, whatever. The granularity of the data writers can vary based on the scope of data pumps and processing units. So it depends. It doesn't mean that it should be just only single data writer. You can have several ones, or so it depends. Next, it will be like this alternatively approach, where here you can see you can have, for example, instead of single data writer, you will have, for example, 4 data writers. For each of them will be particularly designed for data pump. So alternatively, each class of processing unit can have its own dedicated data writers component. In this model, the data writer is dedicated to each corresponding data pump and contain only the database processing logic for that particular processing. This model provides better scalability and agility due to the alignment of processing units, data pump, and data writers. So in this approach, scalability will be bigger, so data writer also will not be the bottleneck in this case, but the database can be the bottleneck in this case. So this is also trade-off. But anyway, the communication is done in a synchronous way. Next is data readers. So data readers take on the responsibilities for reading data from the database and sending it to the processing units. It's via the also data pumps. Reverse approach, reverse things if we will compare with data writers. So data readers are only invoked under one of the 3 situations. When we need to send the information from the database to the in-memory grid. It's difficult cases because as we already know, we don't work with database directly. We work with memory data grid, and this memory data grid should be synchronized by data grid, this cache between processing units. So what will be the cases when the database should be involved in this process? For example, a crash of all processing unit instances of the same name cache. So all of them is crashed. We need to restore data. If without database, then we will lose data at all. So we will read information from the database. Redeployment of all processing units within the same name cache, or retrieving archived data not contained in a replicated cache. This can be such particular cases. Yeah, next will be data collisions that we have to look just one moment. So there are several factors that influence how many data collisions might occur. The number of processing unit instances containing the same cache, the update rate of the cache, the cache size, and finally, the replication latency of caching product. Here we have the formula used to determine probabilistically how many potential data collisions might occur based on these factors. And this looks like in this way. So we can try to calculate this collision rate with such approach. Here we have n, which represent the number of services instances using the same name and cache. So we can play around with this number of services and see how it will affect the collision rates. This value represents the updating rate of milliseconds. So how frequently these updates will happen. S will represent the cache size in terms of number of rows, how many. So as bigger cache we have, as less collision can happen. And last value, it is replication latency of the caching product. So using this formula, it can be possible to try to calculate and see with which data collision you can face. So for example, yeah, maybe I didn't add here some additional examples, but for example, you can say you have number, for instance, will be 5. Cache size will be 50,000 rows. Replicated latency will be 100 milliseconds. Updates also 70,000 per hour. So you can calculate the collision rate and the percentage. So what will be the percentage of these collisions? If you will play with this, for example, you will increase the cache, or you will increase the number of instances, or it can positively or negatively influence and affect these collision rates. Yeah, next, let's take a look cloud or on premises. Actually, this architecture style can also be deployed between these environments. So that's why one of the benefit, because mostly when we have the request that we have to build something in cloud or we have to build something on premise, it will influence for our decision. Some of the architecture styles is specifically designed for on-premises solutions. Some of them more designed as more preferable for cloud. This one offering the unique feature not found in other architectural styles, because it can be deployed like in a hybrid way. What it means, for example, you can deploy on the cloud things that will contain processing units, virtualized middleware to work a little bit similar to microservices. So you will be able to increase your instances. You will be able to have something like a load balancer, data grid, and so on. But if you are worried about your data, you don't trust the cloud solutions, and you want to keep all of the data, maybe they're quite sensitive, on your own side, then you can put all of such data information on premise environment. So like such and data reader and writer, and finally the database will work with the data with on-premise environment. Next is replicating with distributed caching. So space-based architecture mostly relies on replicated caching, although distributed caching can also be used as well, actually. And with replicated caching, each processing unit contains its own in-memory data grid that is synchronized between all processing units using the same name and cache. When an update occurs to a cache within any of the processing unit, the other processing unit automatically updated within this new information that is come to the memory data grid. Distributed caching, instead of replicated, requires an external server or service dedicated to holding this centralized cache. In this model, the processing unit do not store data in internal memory, but rather use a protocol to access the data from a central cache server. So distributed caching supports high level of data consistency. Because what? Because the data is in all in one place and does not need to be replicated. This is one of the benefits. However, the trade-off is that this model has less performance than replicated caching because the cache data must be accessed remotely, adding to the overall latency will be increased in the system. So keep in mind that if you choose space-based architecture style and you still have some flexibility for caching, you can use replicated to distributed. If you will use replicated, then the performance will be higher and the latency will be less, but the data consistency will also be affected. Instead of it, you can choose the distributed, then data consistency will be quite higher, but you will lost in latency and performance in such cases. It depends what is more important for your system. So replicated with, if we will compare with distributed caching, the decision between using replicated cache and distributed cache becomes one of the data consistency or performance and fault tolerance. So distributed cache will always offer better data consistency over the replicated cache. Because I believe you understand why, because the cache of the data is in a single place. However, performance and fault tolerance will always be better when using the replicated cache. What is the final rates for this architecture style? So let's notice that space-based architecture maximizes elasticity, scalability, and performance. If we'll take a look for testing and simplicity is also bad, has low marks as event-driven. Even testability is even less, so it means it will be quite complex to do. And if this architectural characteristic is more important for you, then it shouldn't be your choice. But instead, if you are good, you are well with that, you are ready that it will be simple and testable will be quite hard, but it will provide you high scalability, high performance system with nice elasticity also. So testing gets 1-star rating due to the complexity involved with simulating the high level of scalability and elasticity supported in this architecture style. This is all for space-based architecture. Next, we will take a look for service-oriented architecture style.